A mineral is a naturally occurring substance having definite chemical composition, fixed internal atomic structural arrangement and formed by inorganic processes of nature. Both metallic and non-metallic minerals occur in nature.
The natural assemblage of metallic minerals which can be exploited and extracted profitably and serve as a commercial source of one or more metal values are called ores. All the minerals are non-renewable natural resources. It means that they are not replenishable. Once they are exhausted completely, they cannot be renewed. These mineral resources are associated with rocks of the earth crust and obtained by surface and underground mining operations. As far as metals are concerned, they are extracted from their ores. Primary deposits of precious metals such as platinum, gold, silver, etc. are limited. At present, India is the largest consumer of gold in the world. Silver will be finished by 2020. That is why precious metals are becoming costly day by day. Minerals and metals play an important role in the progress, development and prosperity of man and country as well.
From the primitive man to the most sophisticated modern man, in all stages of human advancement, man had to look to minerals for his sustenance, festivities, decoration and even for his funeral rites. The primitive man, in his efforts to hunt for food and even for self-protection, started using hard rocks and hard minerals which he found so abundantly all around him in nature. Hard rocks like quartzite and hard minerals like quartz, jasper, flints, etc. were commonly used by him either in their natural shapes or after crudely chipping them into some pointed shapes.
The first metals the man used would be relatively soft, hence metal like copper, tin, zinc, etc. were utilized by him. These ages are known as Copper Age and Bronze Age. Following the Bronze Age, the early man had learnt the use of iron in its many forms, known as the Iron Age.
The art and science of manufacturing iron and steel developed in this country from the pre-Vedic times and much faster than the other parts of the world. By the end of 3rd and 4th century AD, that is, during the period of Chandragupta II, India had already acquired the capacity to manufacture that marvel of rustless iron pillar which can be seen near Qutub Minar in Delhi even today. India is self-sufficient in about 35 minerals and mineral substances which are used as basic raw material for several industries. We have enough deposits of iron, copper, alumina, coal, limestone, etc. in the states of West Bengal, Bihar, Jharkhand, Chhattisgarh, Madhya Pradesh, Andhra Pradesh, Kerala, Karnataka, Gujarat, Rajasthan and Goa.
Our onshore, Ankleshwar, Krishna Godavari Basin, Assam, Jaisalmer and offshore, Bombay High regions are rich in petroleum and natural gas resources. Heavier minerals like ilmenite, monazite, uraninite, zircon, rutile, etc. are concentrated in the form of thick placers in beach zones. These placers are extended towards sea. Such placers on beaches and estuaries are mined for metals like titanium, gold, platinum, thorium, zirconium and even for diamonds. The well-known beach placers of Kerala coast are of economic importance and contain rich concentration of monozoite, primary source for metal thorium, along with ilmenite and rutile.
Former President of India, Honorable Dr. APJ Abdul Kalam, suggested the use of thorium in place of uranium in India. Accordingly, By making some changes in our nuclear power plants, we should start using thorium for generating electricity because thorium is available in plenty in India, whereas for uranium, we are dependent on other countries.
Special mention is necessary about the possibility of metal accumulation on the seabeds. Continental shelf and adjoining areas of Indian Ocean are favorable sites for this natural resource. Metallic and non-metallic mineral resources are to be extracted by surface mining as well as underground, both shallow and great depths, mining activities from Earth's crust. Before mining any deposit, different activities are to be undertaken which complete in different steps. They are: searching stage. Search of presence of minerals on the basis of various field and laboratory clues and guides, etc. Exploration stage. It means all phases of investigation carried out for a near realistic delineation of the three-dimensional configuration of the mineral ore body and assessing its economic potential both in terms of grade and reserve, that is, quality and quantity. Exploitation stage. The bunch of operations commencing with the initial box cut removal of the values to dispatching the produce from the pit to the utilization spot comes under the purview of exploitation or mining stage. Extraction stage. After mining, the ore minerals are in association with unwanted minerals. The techniques of liberation of wanted particles, the values, from the unwanted particles, reduction of mineral assemblage to an appropriate size, effective concentration of valuable part, and rejection of gangue portion, etc., for any smelting operation come under this stage.
In India, mineral search is done by geologists, geophysicists, geochemists, etc. of Government of India undertakings, geology and mining departments of state governments, corporations, private sector enterprises, etc. Some of the leading geology and mining organizations of India are
Geological Survey of India, Kolkata; Oil and Natural Gas Corporation, Dehradun; National Mineral Development Corporation, Hyderabad; Coal India Limited, Kolkata; Gas Authority of India Limited, New Delhi; Hindustan Zinc Limited, Udaipur; Hindustan Copper Limited, Kolkata; Gemological Institute of India, Mumbai; Cement Corporation of India, New Delhi.
more than 2,100 mineral species have been discovered in nature. Every mineral has its own diagnostic properties on the basis of which it can be identified and distinguished from the others. Certain minerals have only one element in their composition, such as diamond and graphite, which only have carbon, whereas others may have two, such as quartz and fluorite. In some cases, there are multiple elements such as orthoclase and apatite.
Uses of mineral resources. Metallic ore minerals. Bauxite. The principal use is for the manufacture of metallic aluminium. This light metal has a high degree of strength and it can alloy easily with a number of other metals. Duralumin, which is much favored, is used in the manufacture of railway coaches, goods wagons, etc. It is also used in the production of abrasives, refractories, chemicals, etc. It is a metal which combines lightness with strength and is highly resistant to corrosion. It is a conductor of electricity, hence it is being used in electric wires, cables, etc. Its domestic use is for making utensils, tin foils, etc. Lower grade of bauxite is used in cement industry. Aluminium sulfate or alum is very much used in the paper industry and in water purification. Chalcopyrite. It is the most important ore mineral of metal copper, which is a sulfide of copper and iron, also known as copper pyrites. The uses of copper are many. Due to its high electrical conductivity, its greatest utilization is in the electrical industry. Copper also forms a number of useful alloys. With tin, it forms bronze. With zinc, it forms brass. With aluminium, it forms duralumin, etc. Hematite and magnetite. These two important natural iron oxides serve as iron ores. After proper beneficiation, these iron ores, mainly hematite, is used in iron and steel making as a heavy medium in coal washeries, etc.
We are able to utilize only a very small percentage of the total iron ore production in our country. About 60% of the iron ore production in lumps is exported in its raw and unprocessed form to Japan and other countries. These countries prefer only our high-grade iron ores. This trend may prove to be a very serious drain on our reserves, because although we do have vast reserves of high-grade iron ore, in the long run this may deplete, and therefore it is necessary to start conserving these reserves.
Galena and sphalerite. In nature, the galena and sphalerite occur together. The chief ore mineral of lead is galena, lead sulfide. It is also known as lead glance and blue lead. Silver sulfide is always present, and therefore it is one of the most important sources of silver. Metal lead is smelted from galena. The major uses of lead are in the manufacture of storage batteries, cable sheathing, lead pigments, etc. The chief ore mineral of zinc is sphalerite, zinc sulfide. It is also known as zinc blende and blackjack. The metal zinc is being recovered from sphalerite. Zinc is used for alloying, for galvanizing iron and steel, in the manufacture of white pigments, dry batteries, electrodes, etc. After the recovery of lead and zinc metals, silver and cadmium are also recovered as byproduct. Manganese minerals. The chief sources of metal manganese are the oxide minerals, namely pyrolusite, silomelane, and braunite, etc. In the manufacture of steel, manganese plays an important role. It is used as deoxidizer and desulfurizer during the manufacture of steel. It is also used to make dry batteries, chemicals, in glass industry, in paints and varnishes. Chromite. The only source of metal chromium is chromite, is also known as chromium iron ore. Chromite, an oxide of iron and chromium, is used for metallurgical refractory and for chemical purposes. Chromite forms useful alloys with iron, nickel or cobalt. With iron, it forms well-known alloy ferrochrome, which is used in making stainless steel. As a refractory material, it is used for making chrome bricks, chrome cement, etc. for furnace linings. Non-metallic minerals. Asbestos. Mineralogically, asbestos includes the fibrous forms of minerals of amphibole group. The fibers are generally long, fine, flexible, and easily separated by fingers. The color varies from white to greenish and brownish. The commercial value of the mineral depends on its property of being spun into yarn, heat resistance, etc. Larger fibers are used for fireproof fabrics, brake linings, whereas shorter fibers are utilized in the manufacture of asbestos sheets, boards, roofing tiles, fireproof paints, insulating cement, etc. Feldspar. The feldspars are aluminous silicates of potassium or sodium or calcium. The The feldspars are the most important group of the rock-forming minerals. Feldspars are used in the manufacture of glass, electrical porcelain insulators, for glazing pottery and ceramic wares, for making enamels, etc. Fluorite. It is a fluoride of calcium, also known as fluorspar. It is used as a flux in making steel, in the manufacture of glasses, for the production of hydrofluoric acid and its compounds, for the construction of lenses, etc. Graphite. Like diamond, it also has a composition of carbon. It is also known as plumbago or black lead. It is used in foundries and in the making of graphite crucibles. Due to its very low hardness, it is used in the manufacture of writing pencils, lubricants, paints, and pigments. Gypsum. Gypsum is a hydrated sulfate of calcium. It is utilized chiefly as a retarder in the manufacture of cement, fertilizer, ammonium sulfate, in the manufacture of sulfuric acid, plaster of Paris, sheets, boards, etc. It is used extensively in the making of molds in the ceramic industries. Mica minerals. Due to the excellent insulating properties and high heat resistance, mica minerals are indispensable in the electrical industry. In nature, several varieties of mica occur, such as muscovite, potash mica, biotite, iron manganese mica, phlogophyte, manganese mica, lepidolite, lithium mica, etc. Muscovite mica is mainly used for electrical insulation, thermal insulation, etc. Phosphorite. Phosphorite is of commercial importance in the manufacture of fertilizers, elemental phosphorus, and phosphoric acid. Talc. Pure talc is a hydrous metasilicate of magnesium, and it is the most familiar mineral to mankind. It serves as a base in cosmetics, talcum and face powders, and toilet preparations. Barite. It is a sulfate of barium and chief source for metal barium. On account of its high specific gravity, it is also known as heavy spar. The pure white variety is much favored in the manufacture of white paint, in the production of wallpapers. Calcite. This mineral, carbonate of calcium, is a widely distributed mineral in nature and is also known as calcspar. There are many varieties of this mineral, of which pure, colorless, transparent variety known as island spar is important in the optical instruments. Calcite finds an increasing use in the textile, paper and rubber industries. Precious and semi-precious stones.
When the sparkling minerals occur in nature, mainly in difficult terrains, deep jungle with rarity, they are treated as precious stones. They are properly cut, polished and used in jewellery as gemstones.
Precious stones are predominantly single crystals or grains. Their varied colors, brilliance and transparency make them attractive for ornamental purposes. They have certain specific qualities which make them precious and valuable. The important precious minerals are diamond. Diamond is a pure form of carbon and the hardest mineral known. If colorless, transparent and flawless, it is the most precious among gemstones. The opaque diamonds, which are not well crystallized, are used extensively as abrasives and for cutting purposes in gem cutting, diamond drilling tools, for dressing emery wheels, etc. Corundum. It is aluminium oxide and it is hardest next to diamond. It is used as an abrasive, as a refractory material. Its colored varieties are used as gemstones. Red color variety is known as ruby, whereas the blue color is sapphire. Beryl. It is a silicate of beryllium and aluminium, an only important source of metal beryllium. It forms useful alloys with copper, nickel, and is very much used in aerospace industry and as a moderator in atomic reactors. Emerald and aquamarine are its gem varieties. Relatively abundant in nature, occurring in large sizes, flawless and good colored varieties are grouped under the category of semi-precious stones. Apatite, amethyst, quartz, and its varieties, tourmaline, spinel, garnets, etc., are classified in this category. Formation of minerals. Minerals are natural products in solid state and commonly formed by cooling, crystallization, and solidification of hot molten materials within the earth called magma. When it erupts on the surface through volcanoes, weak plains, etc., it is called lava. Solidification of hot gases near active volcanoes is rather a rare process of mineral formation.
Metamorphism is another process inside the earth in which temperature pressure play an important role in recrystallization. Precipitation and evaporation of mineral forming substances are also important processes in mineral formations. These natural processes take millions of years for mineral formation, and we exploit these resources merely in a few years. If this is the way of exploitation, very soon some mineral deposits will be exhausted and will be categorized in the endangered category list.
Very limited reserves of energy resources, precious metals and precious minerals are left for future. It is estimated that between 1750 to 1900, the population of the world became double, while the exploitation activities increased 13 times. It is also noted that developed countries are using mineral resources of developing countries like India by importing for their progress and development and preserving their own resources for future purposes.
The key to industrial progress of any nation is the development of its mineral resources, which plays a vital role in the development of the economy. Unfortunately, those countries which are rich in mineral resources are a little slow in the race of technological development, while those countries which are ahead in technological development are poor in mineral wealth. Some Arabian countries have rich reserves of petroleum, but because of a little backward technology, they are not able to explore, exploit and refine these products, and therefore they are dependent on other countries for these activities.
India is one amongst the few countries in the world endowed with rich mineral resources which offer a tremendous scope for setting up various mineral-based industries in the country. In India and world, there are large number of basic industrial products which require minerals as raw materials at primary or other stages. With the establishment of many mineral-based industries in the post-independent era, the demand for various mineral raw materials has increased several times, and it has led to the intensive search for the mineral deposits in the known as well as virgin areas of the country. Low-grade deposits, which were earlier not useful, are countries now able to utilize these. Environmental effect of extraction and using mineral resources. Minerals are obtained by the process known as mining. Mines are of two types: strip mine and deep or shaft mines. Deep mining is hazardous because it involves risk of the life of workers and also disturbs the balance of environment. It involves rock and roof falls, flooding and inadequate ventilation. Coal mining is even more hazardous than metal mining. We still remember the Chasnala disaster of Jharkhand coal mines, where several hundred workers lost their lives due to flood. The adverse effects of mining on environment are as follows. Deforestation. Before digging a mine, the trees or agriculture in that area has to be cleaned. Thus, forest and agricultural land are affected. Formation of deep pits. Deep pits dug during mining results in gully erosion. Tectonic plates inside get disturbed, resulting in earthquakes. Dust pollution. The dust produced during mining is injurious to health and causes a lung disease known as black lung or pneumoconiasis. In Piplia, a village of Mandsaur, Madhya Pradesh, mining of slate pencil rocks is cause of silicosis. The workers inhale the dust, which gets deposited in their lungs. The lungs become heavy and a person dies of silicosis. Marsh gas or methane coming out from coal mines is injurious to health. Radiation from uranium mines is a life-threatening hazard. Loss of biodiversity. Due to felling of trees, there is loss of habitat. Several species of animals have to migrate from that area, and at the same time, many rare tree species are lost forever. Landslide. The mines generally have a smaller diameter on the surface and a much larger one in deeper layers. This makes the earth hollow, eventually resulting in landslide. Decrease in lifespan of the workers. The workers are subjected to work in conditions of more heat and less oxygen, due to which their normal lifespan decreases. Soil erosion. During digging, the rocks are cracked open by dynamite. Therefore, the superficial layers of fertile topsoil are lost and soil erosion also takes place. Control measures. Search for mineral resources should be carried out in deserts and tundra areas so that normal fertile land is not disturbed. Bottom of the oceans and new planets are also important for the search of minerals. The deep pits dug during mining should be filled with the waste and garbage from old mines. Mining should be done only in such places which are marked by Geological Survey of India or ONGC or GAIL. Energy sources like coal and petroleum are in limited quantity and are non-renewable. Therefore, uses of solar energy, wind energy and atomic energy should be increased. Old mineral products should be recycled. Plantation should be done near mining areas to restore the balance of environment.